afternoon, geometry students. This is our deductive geometry review videos. And you have hopefully in your possession this document here, which is sort of a review sheet, a bunch of true-false questions and some other things, multiple choice. So we're going to go through this. And you also have this available on your class page. So if you go, this is for my J class, but Mr. Nelson's class does the same thing. And if you look at the final exam review topics, this is the same document that we just looked at as a PDF file, so you have that available. And you also have the solutions. So we're going to be putting this together over the next few minutes. And I'll try to break this up into short videos so that you can take them a bite at a time. Okay, so for starters, we have good old Euclid and his book, The Elements. Which we're not going to read Greek, but you should know that was the first geometry book. You also have Jacob's, which is your textbook, and his book called Geometry Seeing, Doing, and Understanding. Okay, so this is your primary resource, obviously. And I'd already referenced, if you wanted to get started, in Jacobs you have a very extensive glossary that you should be looking at today and tomorrow. The glossary starts on page 728, and it has just about every important fact in there. Also the pages that are referenced where you can find more information. There's also, after about a dozen pages, a section on formulas. Jacob calls it a formulary. A-R-Y, and that's on page 738. So the formulas for areas and volumes of various shapes. And then lastly, there's a section on postulates and theorems. And we covered most of those. There's some that we didn't. But it would be good to look through those if you're unsure about anything. And that starts on page 741. So a textbook is a great reference for some of the review material. Okay, let's start with the true-false questions. And these are supposed to be fairly easy true-false. I'll try to go through these without a lot of grief. Let's see, a tetrahedron has 4 faces. That's true. Tetra means 4, and hedron means faces. So you have tetrahedrons have 4. You have hexahedrons, hex meaning 6. Of course, we typically call a hexahedron a cube, right? Cube. We have an octahedron, octa, which would be an 8-sided or an 8-faced solid. You have the dodeca. You can sort of think dec is 10 and do means 2, so this is 2 plus 10. Dodecahedron. That would have 12 faces. And the largest of the Platonic solids was the icosahedron. And that has 20 hedron. It has 20 faces. Okay, so yeah, you should know that. Tetra has 4. Okay, second one. The central angle of a circle measures the same as its intercepted arc. That's also a true statement. And we can do a quick sketch. Circle, central angle, vertex at the center. And whatever the measure of this is, let's say this is 50 degrees, that's also the measure of the arc, 50 degrees. So that's also a true statement. By the by, if you're looking in your textbook on page 738, they have a very nice diagram that shows arcs and angles of circles. And they have this picture here, and then they have a green arc or a green angle coming like this. And this would be 25 degrees, so this is a inscribed angle in your circle, half of the arc. And then they also have a picture where you have secant segments, some going outside the circle like that, where this angle is half of the difference between these. So let's say this was 40 degrees, and let's say this one was 90 degrees. You take 90 minus 40, that's 50. You take half of that, and that would be this angle over here, 25 degrees. So those are a couple secant segments that meet outside the triangle, and you also have secant segments that meet inside the triangle. And so in this case, you would simply average the 90 and the 40. 90 plus 40 is 130, and cut that in half. So this is a 65-degree angle there. Okay. The Pythagorean theorem deals with obtuse triangles. I hope you know that's false. Pythagorean theorem, right triangles, right triangles. Easy question. Okay, the angles of a quadrilateral add up to 360 degrees. That's true. Draw any quadrilateral, and then you can easily see it split into two triangles. The angles in this triangle add up to 180, and the angles in this triangle also add up to 180. So 180 plus 180 is 360 degrees. So that's a true statement. Okay, number 5, coplanar means points on the same plane. Points on the same line. That would be false, right? Coplanar means points on the same plane. By the way, the word that means on the same line would be collinear. Okay, next question, number 6. The distinguishing characteristic of a definition is the phrase if and only if, and that is a true statement. You might want to go all the way back to chapter 1, or if you just look at the glossary definition, they don't have a definition of a definition. So yes, we should know definitions if and only if. Okay, number 7, an acute angle less than 90 degrees. That's true. So acute angle less than 90, by the way, equals 90. That's a right angle, and greater than 90 is an obtuse angle. Okay, so those are the typical angles that we see. Number 8 is sort of a tricky question. You would have to look at it and ask yourself, what's going on here? An angle has more than one bisecting line. I would probably draw a sketch of an angle and go ahead and bisect it. You know, the word bisect means cut into two equal parts, so this part would be exactly the same size as that part. And then ask yourself, can that angle have more than one bisecting line, more than one? And the answer is no. It has only one. I've drawn it here. It's the one that cuts the angle into two equal parts. Okay, so there's your first 8, all worked out nice and simply. Let's look at the next 8. By the way, note the little comment there. Drawing sketches are often useful. I would recommend that you draw lots of sketches as you go through this particular review. Okay, all squares are congruent. Let me see if we can get the pen working here. All squares are congruent. Well, congruent means same shape, same size. Here are two squares that are certainly the same shape, but not the same size, so that would be false. By the way, all squares are similar. Similar simply means same shape, and they're all shaped the same. But congruent, so sad, that would be false. Okay, number 10, all equiangular triangles. That's sort of a strange, we usually say equilateral. Equilateral, meaning same sides, or the sides are all the same length. Equilateral, but this one talks about equiangular. And so the question is, are all of those similar, equiangular? So let's sort of think about that for a minute. We know the angles of a triangle add up to 180, and if they're all the same, they would all have to be, let's see, 180 degrees divided by 3, which is 60 degrees. So each one is a 60-degree angle. So now we have 3 60 or a 60-60-60 degree angle triangle, and you should know from the isosceles triangle theorem that is an equilateral triangle. Okay, so we have the idea now. Now are all those similar? So that's the task. If I draw an equilateral triangle, and then I draw another equilateral triangle, will it have the same shape? And the answer is yes. So all of these are going to be 60-degree angles, and it doesn't matter the size of the sides relative to each other. Right, so these figures are similar. That is a true statement. Okay, parallel lines must be in the same plane. That's true, and in fact, if you look at the definition of parallel lines are by definition, page 118, lines that lie in the same plane and do not intersect. So yes, they must be in the same plane. That's a true statement. Number 12, lines that do not intersect must be parallel. Okay, so this is sort of a tricky question, and here's why. Consider a cube, or our hexahedron as we called it, and I'm going to highlight a couple of lines. Here's a line. This is the top edge of the cube going like that, and then I'll highlight another line, this back edge over here. Now you sort of have to envision what's going on here. Think of a box. If you have the front edge of that cube and this back edge, those lines will not intersect. It sort of looks like they cross here, but of course they don't. And you can just take a small model and convince yourself. So no intersection, no intersection. And the question says lines that do not intersect must be parallel. Well, obviously this blue and green line are not parallel, So that is a false statement. By the way, lines in the same plane that do not intersect, yes, they must be parallel. These particular lines that I've drawn on the cube here are called skew lines, and skew lines don't lie in the same plane, and they do not intersect. Okay, so let's see. Number 13, all 45, 90-degree triangles are isosceles. Let me get a little sketch going. There's my right angle, and let's see, 45 degrees and 45 degrees. So the question is this an isosceles triangle? And that brings to mind the isosceles triangle theorem. The isosceles triangle theorem says that if you have two sides that are equal, then the angles opposite them also have to be equal. We're sort of working the converse of that for this problem. Here we have two angles equal. Does that require the sides opposite them to be equal? And the answer is yes. So this is a true statement. All 45, 90 triangles are in fact isosceles. You might want to think of this, by the by, as take a square, which you know all four sides are the same, and all four angles are 90 degrees, and then just cut it down the diagonal. And sure enough, this red triangle here is a 45, and 90-degree triangle, and yes, it has to be isosceles. Okay, so that's a true statement. Number 14, all rectangles are equiangular. There's that word again, equiangular. So equiangular means the angles have got to measure the same. What do we know about quadrilaterals? A quadrilateral, we knew from earlier on, they have to add up to 360. So if 360, and there's four angles, divide that by 4, and you get 90 degrees. All of these are now the same, 90 degrees, and sure enough, that is a definition of a rectangle. All rectangles are equiangular. Absolutely true. So I'm going to put a true there. In a parallelogram, the opposite sides must be equal. Let's draw a sketch of a parallelogram. Nothing special here. We want to make sure that opposite sides are parallel. We do that by indicating little lines. So now the question is, are opposite sides also equal in length? And the answer is yes. If you look at parallelograms, page 265, there's a number of different theorems about parallelograms. The definition says opposite sides are parallel. One of the theorems says that opposite sides are also equal. So yes, these guys are equal. And by the by, we should also mention, while we've got the picture, opposite angles are going to be equal. So I can do this, right? Opposite angles are going to be equal. And the last bit is if you draw the diagonals, they will bisect each other. So this will be the same as that, and this will be the same as that. Lots of properties of parallelograms. Opposite sides must be equal. That is a true statement. Okay, number 16. Points in the same plane are collinear. Well, that sort of falls back to what we had up here, right? Coplanar means points on the same line. Points in the same plane are collinear. That's false. A little sketch would show that. Here's 3 points. I've drawn them on a piece of paper, so they're on the same plane, and certainly they are not collinear. Okay, let's see, what's next? 17, 18, 19, and 20. Whoops, let me get rid of some of these other circles here. Okay. Away. Okay, formula for the circumference of a circle. So we're going to have to think circle. Circle formula. Circle, the circumference of a circle is 2 pi r, or another way of doing that is pi d. So this is a true statement. By the way, the area of a circle, area, is pi r squared. So you should know that as well. This particular question, number 17, addresses circumference. Okay, number 18, a pair of vertical angles could be complementary. So a number of ideas here. First of all, let's draw some vertical angles. Okay, so this and this are a pair of vertical angles. By the way, the obtuse ones over here are also vertical, but let's just concentrate on the blue ones for starters. Okay, so let's see. We'll take these green ones out of there just for a second. Now the question is, could these 2 angles be complementary? That's the question. Complement, what does complementary mean? You would have to look at the definition. Complementary means 2 angles that sum or add up to 100 or 90 degrees. 90 degrees for complementary. The supplementary, we'll get to that in just a second, they sum to 180. So could these 2 blue angles add up to 90? And the answer is yes. We know they have to be the same, and if they both happen to be 45 degrees, that would be 2 vertical angles, a pair, that would add up to 90. So that is a true statement. Interesting question. Okay, the 2 acute angles in a right triangle are supplementary. So again, I think a picture will make sense. Again, the word supplementary means has to add up to 180, add up to 180. So we have a right triangle, and we have these 2 acute angles. Here's our right angle, that's 90 degrees. And the question is, can angle A and B add up to 180 degrees? Well, I would hope you would say no. We know that all 3 have got to add up to 180, and we already have 90 degrees here. A and B cannot add up to 180. A and B, in fact, have to add up to 90 degrees. Add to 90 degrees for these 2. Okay, so if the question read, the 2 acute angles in the right triangle are complementary, it would be true, but as it states now, it has to be false. Okay, the argument, if A, then B, and if B, then C, therefore A, that's called a syllogism. That's a true statement. A little bit of terminology on logical deductive thinking. Okay, again, you might want to go all the way back to the glossary or look back in chapter 2 where we talked about deductive reasoning. Okay, number 21. Let's make sure we got these all. This is true. This is true. This is false. This is true. 21. The perimeter of a rectangle with length L, and width W is supposed to be L plus W. Well, that's a false statement, just on the face of it. Perimeter means distance around. This would be L plus W plus another L, right, plus another W. So to find the perimeter, you would have to have 2 times L plus W, or 2 L's plus 2 W. Okay, so that's a false statement. Geometric constructions are made with straight edge and compass. That's absolutely true. You will have to do a couple of constructions on the exam, and we'll get to those in just a little bit. Protractor, used to measure the radius of a circle. Well, let's think what a protractor looks like. That's the instrument that looks like this. It has a hole, typically, and some marks going around, right? Certainly not to measure the length of the radius, but rather they measure angles. So protractors measure angles, not the radius. This is a false statement. Bisect means to cut into two equal parts. We saw that earlier when we were talking about the angle bisector. That is the definition of bisect, cut into two equal parts. That's a true statement. Okay, pictures, 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 more pictures, 25 through 29. Let's see if we can knock those out quickly enough. All circles are similar. Okay, similar means same shape. So do these have the same shape? That would be true. Are they congruent? No, they're not. Could they be congruent? Well, they could be if they had exactly the same radius. So if this was 5 and this was also 5, now we have two circles that are congruent. But the question talked about similar, and so that's true. A ray has two endpoints. Okay, ray. Let's draw a little sketch of a ray. You should have an idea, a point, and all the points going in a particular direction. This is a ray. This is called an end point. So rays only have one endpoint, two endpoints. That's false. Decagon. Deca, I think we saw that earlier. Deca has 12. No, that's false. Dodeca has 12, but a plain old deca only has 10. So that would be 10. This would be 12. So deca has 12, false. A regular hexagon has 3 radii. We need a picture of a regular hexagon. Okay, so let's think about how we might want to draw that. A regular hexagon, we know we have 6 sides. Hex is 6. And regular means all the sides are the same and all the angles are the same. So here's our little picture. By the way, this is a 120-degree angle if you needed. And because it's a regular hexagon, it's cyclic. There's a circle that goes through all 6 vertices. I'm trying to draw a circle. And there is a radius of the circle that goes like this. Okay, so it goes from the center, the circle center, and the 6 radii go to each of the vertices. Well, it says there's only 3 radii. That's false. I just drew a picture. It's got 6. Okay, so let's go through these again. All circles are similar. Yes, no, and no. Number 29. The 3 medians of a triangle are concurrent. So yes, there's a whole chapter on points of concurrency. So we have our triangle. If we find the midpoint of each side, let's see, this looks to be about the midpoint. That and that are the same. This looks to be about the midpoint. That and that are the same. And this looks to be about the midpoint. That and that are the same. Connect the midpoints to the opposite vertices. These are called the medians. And sure enough, they all meet in the same spot. And you should know the name of that point of concurrency where the 3 medians meet. So yes, this is true. And there you go. Okay, so let me stop this little video here. Let me see how much time we've got running. Okay, we've been running, wow, 23 minutes. Okay, let me stop here, and I'll try to go a little bit faster for the next page.